Hi, it's GadgetUK here again, back for a quick follow-up on the SID card. You can see here we've got a new revision of the PCB. This was created by Call286. He took into account lots of the design issues, suggestions and things that I pointed out at the end of part 1. Actually, I'll stick a link above. You can see here, look, Tower of Insanity. He's put some funny things on here, so yeah, I was referring to the pile of sockets I had there with, adaption for the address selection as the Tower of Insanity. The funny thing is, the guy I think who manufactured the original one, SJW32, I think he's selling some of his original boards on eBay, and I noticed in one of his pictures using a still of my video with my A500 Plus with the card I built there, with my carpet in the background. Yeah, he didn't ask me, but anyway, I'm not too fussed because obviously it was nice of him to create the original one. But yeah, so this is a follow-on from, it says there, based on the works from Christian Bayer, SJW32, with massive help from Live2, GadgetUK164, and as I say, it's Call286, and it says Call286 as routing imp. Yeah, as seen on GUK164. Well, that's quite funny. I like that. I think there's a few other things on here. What's this here? Keep away from mobile ESD generators. That's a reference to my cats. I've described cats as mobile ESD generators in the past, and they blooming well are. So we've got the jumper area here for the address selection. That's quite nice. We talked, I think originally he was going to do dip switch, and I was like, well, if you do that, you're going to need pull downs or pull ups or something. It might be easier just to stick some jumpers. It's probably slightly cheaper maybe than having a dip switch. So that's what we've gone with, or I should say, that's what Call286 has gone with. You can see this is the birdseed version here, so it's really nice that it's come pre-assembled with all the, well, most of the SMD resistors and caps on here. That just takes a lot of the work out of it. It's just like sockets and jumpers and stuff and caps, well, and transistor as well. And obviously, then you can stick your SID on it. But yeah, if you've not watched part 1, it just allows you to plug this into a Zorro slot in an Amiga 2000, 500 with the MATSE adapter there, or a 3000 or a 4000, and you can play SID files or use Frodo, and I'll show you Frodo within this video. With Live2's help again, between us we hacked Frodo. So the board itself was kindly sent to me by Barry, again at sparxUK, so I'm very appreciative of that, Barry. It's fantastic, and he's even taped the chips in place here, the main 3. So all I need is my SID, a few jumpers and things, some caps and a transistor, and the sockets and things. But it's going to be really quick to whiz through this, so probably won't even show you much of this build. We'll just get on and I'll show you I'll talk about some of the things I wanted to follow on with. So you can see I've anchored that there with a little bit of solder there, a little bit of solder there. It's not obvious where pin 1 is here, and it's on the left here. I think there's a line that's a bit longer on the outline there than there is on the line in the bottom. Yeah, can you see it there, the white line? It overlays on that first pin. So that's the clue, I'm assuming. Can't really see for the tape. It's going to be the same here. I think there's a line that's a bit longer. I think it's that top one there. That's going to indicate pin 1. But anyway, we've anchored it to those 2 points. That was really fiddly, actually. I'm surprised how hard I thought that was. It felt quite difficult. I'm not sure it's perfectly straight there, actually, but yeah, the solder can be deceptive. When you've got solder on one pin and none of the others, it can look a little bit crooked. But anyway, I'll get some flux on there, and I'll show you the drag soldering. If you're not very good at small SMD stuff like this, you know what? The other version of the board might be better for you. So you could build either. There's just a few tweaks and improvements that this board brings, but you can do everything we're doing here with the original one. So trust me, it's tiny, this IC. I'm using 0.7mm thick solder here. Look at the size of my finger, my thumb. It's teeny little thing. Anyway, let's just get some flux along here. And then I'm using the Antex here because it's got a wedge tip. It's the best sort of thing for this, really. Something that's got a nice long flat area, because then you'll pass the heat a lot better, and I won't need very much solder at all. That's way too much already, I think. So let's remove the solder, and then I'll just have a little drag along here. You can see that huge blob, look, oh, it's gone now. And that's one of the benefits of having good flux. Bob in and bob out. And then I'll just inspect with the magnification to make sure we don't have any joins. But yeah, you've seen that one. I'll just whiz through the other ones. There's nothing really more to show you there. There is something worth showing you there. You can see we've got a large blob of solder there. It's very difficult with this cap in the way, so I've ended up with a little bit too much in this corner. So use a bit of braid, and as you can see, just suck it away. And then it's a case of trying to just have a bit of reflow. Don't add any more solder, just drag along. Do the bob in, bob out as well if you need to just tidy it up a bit. I think that's it. So I'll just inspect. Hang on, I've got another bridge now, I think. There we go. I'll just inspect with magnification, but anyway, you get the idea. Just clean as I go around here with some IPA, just so it doesn't get all sticky. That's not bad for the first one. I just get a tiny, tiny bit of solder on the tip there. That's probably way too much. Anchored it on the ground here. That's the position on that one. And just have a little drag along here. Ground absorbs loads of heat there actually with this iron. I'll have to use the other iron just to reflow that one point. The reason being is this iron doesn't have anywhere as much thermal capability, so let me just use the Heiko on that right hand pin there. I'm not sure I can see even with a macro. Yeah, there we go, you can see, managed that. So I need a cable just like this one for the other SID card. So I need a Molex connector and a clip. And obviously I need 2 pins to go with that. So I've cut 2 pieces of wire about 1 inch or so longer than this wire, yeah? We'll start by getting this connector on first. And I've talked about doing these before actually, probably on the Sega Megatech video, but the way I do these is I don't crimp them, I sort of use magnification, hold it there like that and solder at that point on there. So I've got the blue one in, soldered the black wire, the little notch faces upwards like that, and it should slide in and click into place hopefully. It's going to need a little push I think, it's sort of stuck here. It's probably because of the bit of solder has made it. There we go, it's gone in now. So those are both in. And I thought I'd show you this just because I've not showed it before. How do you get something like that? Well, you just literally just twist them together. So you could twist here to start with, like that, just until you've got a number of twists in there. And then start, using the wire, otherwise you'll damage the solder points and stuff there. And just keep twisting like this until you get them joined together. There we go, all twisted together. So we can now get the connector on. Now, on the last one, part 1, and on the previous video you saw I use these. I've used these quite a lot for mods, and they work quite well. They'll grip pretty well there, but they can get knocked off. So I've gone with a different one here. Can you see it's got a hook? So that should be a bit more reliable. It's a bit bigger, these are the things you need to think about, it's a trade-off. It's more reliable in terms of connectivity, but a bit bigger physically, but I should be able to fit that in there. So anyway, I'm going to do that. And just like last time, I'm not going to use the ground, not going to have a clip for the ground. We will cut that off somewhere here. And that'll just get wrapped in heat shrink, have some heat shrink on the end here. So let me just think about this. It wants to go in a certain distance here, doesn't it? Let's just try and pull the end off there. Yeah, you manage to just retwist it again if they've separated a little bit. And if you've got any irregularities, in terms of the distance of the twists, you can just revisit and have a bit of a twist like that, and then it looks nice. So I'll get the heat shrink on there next, and then we'll fit that on. And I completely forgot, there's a resistor required actually, so let's just tin the end of that wire there. I just cut a little bit of the blue wire off here. I've cut the legs off of the resistor. Let's just tin the resistor legs up there a little bit if we can. It's wheeling around all over the place here. I just want a little bit of solder on. Get the heat shrink over both of these wires here, because we're going to encapsulate the black at the same time as covering over the resistor. Slide that back, get some solder. I tend to put connections like this in line with each other and just join them, side by side. But if you wanted a better connection, you could literally leave some of the resistor leg and loop it around the wire. That would give you a better connection, but yeah, you see that's a bit weak there. So anyway, I'll redo that. Yeah, that's not too bad. I mean, it's not going to get pulled on this, so it really isn't a big deal. Yeah, there we go, that should do. So the final thing is just to pull the housing off this. That's going to go through there. You could do with a knot really, but yeah, I really haven't left that much wire, have I? We'll join onto there. Really should have a knot or something here. That would act as a strain relief, but I'm not overly concerned because, as I say, this is just going to go inside my Amiga 2000. It's not going to get pulled, is it? And let's just add some solder there. There we go, that should do. So this goes straight in the middle as far as I can gather. So I did desolder that and then just put a larger piece of heat shrink there because the piece was not long enough. So just shrink that 120 degrees here. And that will do the job. So this is filmed at a completely different point in time, actually, months after the bits you've just seen. sparxUK was having a problem where one of his speakers connected to a SID card or headphones were getting warm after a very short period of time. So he was concerned there was some like a DC bias or something like that. So I spent some time just confirming with him he's got it wired the same way as me, which is the positive side of the output here, you know, where the capacitor goes. The positive side goes through the capacitor, the negative of the capacitor comes down to the audio input on this amp, then the audio output on this amp, which is coming through the negative of this capacitor here, so it's AC coupled, comes back into where the negative is there. So that should mean that you've got no DC potential for a DC bias. It will have been filtered out by that cap, and then if this introduced one, it's filtered out by that cap. And I looked at some reference schematics for the LM386 op amp there, and that's exactly how they recommend you do it. I think the only difference I saw there was a 10 ohm resistor between the output and ground when connecting it to, say, a speaker of, I don't know, 12 ohms or something like that. So yeah, I'm not sure if that little amp replicates that or not. So the next stage was to scope it. And that might be a repair actually, because I couldn't get the scope on for about 10 minutes of switching it off and on, and it wouldn't come on. But anyway, I'll stick the screenshots up because obviously I photographed this as I did it. In the first image there, you can see the voltage level. Now bear in mind the potentiometer, if you adjust it, it can go all the way from like 0 volts all the way up to roughly 12. You got obviously the swing from the supply rail there between ground and the supply rail. Makes sense, that little audio amplified board goes up to 12 volts. So, you know, I'd set mine to about halfway roughly, which is why it shows 6.7 something volts there. Now, and obviously, and I know that is the issue because you can reduce it and go all the way down to 0 more or less, and increase it and go all the way up to almost 12, I think. I didn't go that high because I don't want to overdrive what it's connected to. So then the next thing I confirmed with him is, because of that voltage difference, this is why I added the 1K, just as I did in the first video, and I explained if you're going to connect this to a motherboard, you really want that 1K in series. And I measured the voltage there, and you can see the second screenshot. So in the second screenshot, it was just less than a volt, about 800 millivolts on average, which is roughly about right for line level, and that's why it sounds perfect with the potentiometer set the way I have. So that still didn't answer the question of why was his speaker getting hot and stuff. Well, it perhaps did. That without the resistor there, on this in this application here, the voltage level would be too high. It would be 6 point something volts on my SID card, the way my potentiometer set. Well, if you feed you know, 6.7 something volts roughly into a little speaker, if that speaker's not beefy enough in terms of its power capabilities and all the rest of it, it's going to get hot. It's going to be overdriven. But there's no DC bias. So then, just to be sure, I measured on here. So if I just connect this ground up somewhere, let's just connect it up down there. This is actually on. I shouldn't really be doing all this while it's on. So we've got it connected to the output here, yeah, through the resistor. And you can see, without a swing SID in there, there is it's flatlined here, yeah, because there's no SID in. Now this is the interesting thing. Let me just put the SID back in. I've got the wrist strap on here, but what I want to show you is there is some noise with this swing SID. I'm not really sure why this is happening, but just watch. Switch it on. Scope is now connected up to the output there through the resistor, and we've got 1.7, 1.8 volts roughly. Pretty much locked on frequency of 125 kilohertz. The SID, the SID seems to be producing that. It's either noise that's coming through from the crystal. Well, there isn't actually. Oh, there is a crystal, but the crystal. Oh, hang on a minute. Yeah, there is a crystal. So it could be some noise that's coming through the SID here. And then bear in mind, if you put a genuine SID on there, you're not going to have this. That 125 kilohertz, it's got to be coming from there. How can we be sure? Well, I tell you what, I've got somewhere here. I lost where it is now. an ARM SID. Let's just try an ARM SID and just see if there's any difference here. Do we still have this here? You know, the easy thing to assume here, and Liv2 pointed this out, and it was the first thought I had, is over 100 kHz must be switch mode. Maybe it's coming from the ATX power supply that's powering the Amiga. Maybe it's coming from the scope. I did have problems powering this on, as I said. Anyway, let's just swap that Nano Swin SID for an ARM SID. Let's just try and get this out. They are pretty easy to get out, actually, within round pins like that. Certainly with the sockets I've used here, so let's just get that in. So the ARM SID is in. Let's just connect the scope pro back up again, because that just came off. Wow, there's a huge difference. We've now got 4 volts. How have we got 4 volts coming out of that? That is really weird. But it's not oscillating, is it? We've just got the bias there. But how does that make sense? You can't have a DC bias, it's going through a cap. This is what I'm just getting really confused working on this, if I'm honest. Let me just boot that up, make sure the ARM SID actually works, because I haven't tried an ARM SID with this card, so I guess that'll be something else covered in this video. I think we looked at the back SID earlier, that wouldn't work properly. Yeah, you can see here, look, 10 volts, but I have been playing with that little variable resistor, so let me just adjust that, I'll turn it down. Right, that's a pretty good level. So I'm just going to unclip the scope. Yeah, you see straight away there's a difference in behaviour there, because that's really quiet now. So I'm now going to need to turn it up. It's probably because there's no load. Let's increase that a bit. Yeah, so apologies, it's raining, but that sounds okay. So the ARM SID seems to be working. Yeah, you can see there we've got a bit above line level. I'm not sure if you can see that. We're around 1 volt, just a bit more, 1.2. That's why it sounds okay like that. But if I was to unclip that and clip it straight on here, you can see now it floats up quite high, 6, 7, 8 volts. Yes, the stuff I did with the scope there didn't really reveal much, other than the fact if you use an amplifier like I was doing, in my case it can go, you know, from 0 volts to 12 volts on the output, depending on how that little variable resistor's set. But there are a few things I thought just worth pointing out here. So you can have your audio output from the amplifier and then just tap off here and have a voltage divider, yeah? So, I don't know, 10k, 1k maybe. And then you've reduced the DC offset to start with there, and then maybe feed that into your capacitor. And this is another point, I've drawn the plates the same size there. That might be a better solution, because, and I can't honestly remember, I'm adding this bit right at the end, I don't know whether we saw negative swings. We may do. There may be, you know, positive and negative swings because of the nature of the amplifier circuit you've got, you know, on the other side. I think not, actually. I think it's just reference to ground up to 12 volts. So I think in my case here we don't have that issue. But if you had an amplifier where you can get negative swings, you know, as like a minus 12 volt rail and a plus 12 volt rail, etc., then you would have it's swinging into the negative side, and then an electrolytic capacitor here, it's not going to work very well, is it? You want a bipolar cap, or a ceramic, or something, well, maybe not a ceramic, a polyester or something of the right size. And the size of that cap there, you can filter frequencies out. You know, you've got an RC circuit here, so depending on the sizings of these things, you know, you could filter, you know, certain frequencies out. So you need to be careful what size cap you use, and the sizes of the resistors here, maybe a bit lower than that, 470 ohms or something, depending on what level you're going for and stuff. And yeah, the size of that cap, let's say if you go too low, like 1 microfarad, you'll probably block some of the low frequencies. You know, you might need like 22 or 100 or something like that. And then the other thing that, and I wasn't aware of this, I read this online, is this benefit in putting a resistor there. And I think this deals with pops and things, depending on what's actually driving this. It helps this cap not get charged up or something, which I find hard to understand. Alright, you're going to have a DC offset coming in this side here. Quite how putting a resistor there helps, I don't know. And the sort of standard size with that suggests is 100k. But of course there are formulas, many formulas you can use to calculate all the different aspects of the circuitry here, including what frequencies, you know, may get filtered out as a result of the RC side, but also, you know, the voltage divider stuff here. You could make that a variable resistor, and then you can just, you know, scope the output and get it the level just right. So in general, the whole point is with the issue Sparx had, capacitor here will block DC. This point here can charge up, and I think this helps mitigate pops and things as the signal, as it's first outputs the amplifier. But from what I understand, you can get current, you get bias current issues, and maybe this helps mitigate against that. I don't know. I honestly don't know. I didn't do enough in terms of this sort of thing, and it's like 30 years ago or something, so I honestly can't quite remember. If you know more about this and you can think of a better way to, couple these systems here, the amplifier that I used to, I don't know, headphones or line output, etc., please post in the comments below. But effectively, we had, it going straight out here like this through this cap. We don't have that resistor, and then, I've fed it through another resistor here as it's going into the Amiga audio. So there's going to be, that's going to the place it goes in, you're getting a voltage drop because it's going, I think it's going through a resistor or something there. I honestly can't quite remember how I got that wired. But the point is, when we scoped at this point here, after adjusting our variable resistor, we were getting, we had around just under the 1 volt mark, and then there was no issue at all. It's the line level, it sounds okay. But then it becomes a point about impedance, and this is the thing, this is why things like this can get quite complicated depending on what you're actually coupling it to. He was plugging headphones in. I don't know whether he'd done what I'd suggested and put that resistor there, whether he'd got the level adjusted so that it was, less than a volt. And line level in general is one of those things that, I'm saying less than a volt. I saw something on Wikipedia that suggested that line level, there's a few different standards for it. It can be up to 2 volts, but it depends on impedance again, and it depends on the decibel range of what you're trying to, match up to, the equipment you're trying to match up to. Impedance is the key. Yeah, anyway, I don't profess to be an expert at this stuff. EEV blog is the place I would go to for advice. So my crystal has arrived, the 1 MHz and 33 for something else. But nevertheless, it has arrived, so I can get rid of, as you can see, I've been using the dip crystal upside down there. It's one of the square ones. But I can get that off and get one of these on. I may need to add a bit of flux, actually. That's the ground, I can tell, because it's like trying to solder concrete. Then cheap braid like this will super wick. There we go. See, it's just like an instant silver, and there as well. Look. That's the difference the flux makes. It just gets the capillary action working super well. There we go. That's almost clean enough, I think. Oh, stuck it down. If you do stick braid down like that, just be careful. You don't want to pull the pad. Anyway, we can clean around here with a cotton bud now and get that crystal on. Yeah, this is the problem here. It's not obvious where pin 1 is, so I now need, I think, to do a pin out. It looks square as well, can you see that? It's like a rectangular component, it's a square pad, but I think that's deceptive because it's going to sit in between in the middle. So I had a look on GitHub actually at Call286's project for this V2 of the SID card here. I think it's called Amiga SID actually. And the crystal, pin 1 is down here at the bottom left, so it's sideways aligned, with pin 1 to the bottom left. Anyway, let's just try and get a little bit of solder. I'm just going to move it a little bit. And of course, hot air is far easier. Let's just get a little bit of solder on there. I can always shift it because it's going to move. It has moved, look. It's just the way I try to do these things, just for, well, it's the way I do them. I'm lazy, you could argue. It's like sucking itself this way because of the solder. Hang on. Good God. It doesn't help that that tool is sticking to it. Let's just try and do it with a cotton bud. I think my tool's magnetic, and obviously the can's probably magnetic, metallic. There we go. That's not too bad. And it still needs a little bit of a move actually. It's just a bit far up there. Yeah, that'll do. Right, let's get a little bit more solder on. Yeah, if you added some blue tack to something like this, obviously it would make a really light work of it. You can see that there's not much clearance there on those pads. And it's obviously important you don't ground with a can, or put VCC to the can. The can's probably grounded already, but we'll just get a little bit of flux down there. I don't know what's going on with this flux recently. I have to squeeze it really hard. It just means we can just, you know, bob into these and get a really nice flow on them. I will inspect with magnification in a sec. Yeah, those two are alright. And I can perhaps show you on macro actually, so you can see what solder point should look like on something like that. There's certainly bigger pads on this side, you know, more of the pad exposed on that side than on this side. There we go on super macro, so you can see that's what this should look like. You've got to be very careful not to join the solder onto the can there, but yeah, those look okay. So let's go and give it a try. So the jumpers here you can use to set the bit pattern on the address lines that we're matching on here to move this into a different, you know, Zorro address space. So the way those are set now, they're set to work on a 2000 or 500 with the hacked executable, you know, the SID player and Frodo. And in reference to that, a credit again to Liv2 for helping me hack Frodo that way as well. Yeah, we heard the ding there, using the TF4060 here to test this. Yeah, and this is the 1084S we fixed 12 months ago actually, you know, where we had the problem with the coil horizontal. Because we've got a CPU with an MMU here, we need to go into, I think it's Frodo SID card, yeah, and do enable SID. And that just runs some little patch into the MMU address space to ensure that it's addressable, the SID card. But you don't need to do that if you've not got an MMU. And if we go to Frodo, so this is the executable Liv2 modified, so I've got SID emulation set to SID card there. You can change that to 6581.library, so you can use a library, you know, play SID, but I'm using the actual SID card there. Yeah, so it's 270 odd % there. Looks like it's running really, really fast, but well, you'll find when it starts doing video stuff, it isn't. To get the asterisk, I'm pressing the numpad there, you know, the numeric keypad. Loading from 0801. There we go, it's loaded. Click run. So that is actually coming from the SID chip on the SID card. It's ridiculously fast there, isn't it? But trust me, this is pretty much the only way really to play this at the moment. So I've got title screen in one bit. Yeah, so a bit faster than you might expect, but it does work. Yeah, and we're using the Mega Drive pad here, and video top right to that, and you can see we can play Ghosts and Goblins in one bit with the actual SID. And yeah, it's slightly fast, but it's pretty good actually. If we try it in its normal colour mode, let's do that, you'll see, and look, we get hanging note. That's something to point out. Because the reset line on the SID card is not connected to the 4000 video slot reset pin, it can't stop the sound. So if you've got a note playing when you just stop some software, you will get hanging note. Yeah, so it's the same thing again where it's squashed up, and look, you can scroll across. That is so annoying, and there you go. You've got to just tap the cursor, tap the mouse slightly to the side to get that just right. But nevertheless, I thought I'd show you this anyway, just so you can have a realistic expectation of how Frodo works, emulating a C64 to use a SID card. So this is not going to be for everybody really. You really need a fast 060, and you need a decent RTG card, I think. I mean, that is so much slower now. Just look, just by the fact we've got colour, it's borderline, well, not borderline, it's unusable like that. So yeah, even a fast Amiga is not up to emulating a C64. No. Let's see what this is like actually in game. So title screen looks alright, but scrunched up. It just goes to show though, the VIC, you know, the emulation of the VIC side really hammers an Amiga. There we go. Extremely slow. So it's a shame it's that slow. I reckon even with 100 megahertz 060, you wouldn't be much better off than this. And of course there's probably ways to speed that up in the emulation settings. I'm sure there's a few corners you could cut in terms of compatibility, you know, to give you a bit more performance. But nevertheless, it works. I'm glad we got it working. And of course, if you tried this with maybe a Pi Storm or something, well, maybe that would be the best solution, because you've got RTG with a Pi Storm, and the Pi Storm does, can run really fast, like a pretty fast 040. So I think the video side, the bottleneck there, using a fast RTG implementation on the Pi, you might find it's actually usable and playable. I don't know. Watch this space, we might revisit with the Pi Storm. But it does work. But of course the main use for this is just with Deli Tracker. So, you know, we'll just load up Deli Tracker here. Let's have a look at Ben Dalglish. I was playing some Ben Dalglish on the Prelude video actually. Let's load Avenger. I didn't realise he did the music for Avenger. That sounds fantastic. Yeah, really impressed with it. So the work Call286 has done is incredible. It works really well. Thing bounces back, that's a cool one as well. And it's worth pointing out, at this point, this SID card has been in this 4000 for 2 years, and I've used it a fair bit. So you've got your jumper position up here to switch between 9 volts and 12 volts, and then your 9 volt regulator goes here, because remember 12 volts comes in, maybe on one of these end pins actually, so you've got 12 volts already. You don't need the regulator if you fit in a 6581, but if you fit in an 8580, you want the jumper over here to switch to 9 volts, and you want the 12 volts to 9 volts, you know, the step down. The 9 volt regulator there, 7809. Yeah, it was nice to change to all these SMD components. Yeah, a bit fiddly to assemble compared to through hole, but it's come out really well. He's mounted one of the chips on the underside there. There's a bit of flux on there, look still on there. So this needs to go through the ultrasonic, I think. Although with my sticky pad holding that down, that may come loose. So I'll probably just, you know, manually clean this with a toothbrush off camera in a minute. But it's come out really well, and yeah, I like these things. It's quite fun. There'll be a link to the board layout for this down below, where you can, you know, go away and order one. What I would say is, for the next revision, maybe take this basic, you know, LM387, is it, or 386 op-amp circuit here, and, you know, build this on there. That would be really cool, I think. You know, it could be an optional thing. And the only other thing I didn't cover here is there's a pad there where it says, you know, to SID, it's the reset. So when that's bridged, as it is as default, it joins up the pin, you know, the reset pin on the SID down to the reset pin down here somewhere. I think it's one of these pins here, actually. But you've also got a breakout somewhere, it's there actually, for the reset. So just some additional footage to share with you here. So as you can see, I am surrounded by SID cards at the moment. There's one in my 4000 at the moment. I forget which one, I think it was the first one I built actually. So I built a couple of these actually because, well, these guys have done me some immense favours, and they're kind of like trades. They're kind of like trades actually. So I've done, which one's this? Now this is the one for Stefan. So this is got the jumpers configured here, and the capacitors for the filters for a 6581, because Stefan has sourced a 6581. So I'm going to leave this Nano SID and he can test it and see how he likes it. They're pretty cheap, these, around £10. But nevertheless, that's the one for Stefan, and I just came to test it, and it worked okay actually, but then I tested it with a cable I made and had a problem. Now I built this one here for Stephen Leary. Again, this is kind of like a trade. So yeah, this one's obviously just wired for the Nano SID. If Stephen wanted to fit a 6581 or an 8580, you'd have to, you know, put the filters on, and a regulator for the 8580. It's the same with this one. If Stefan wants to use an 8580, he'll need to maybe fit the jumpers, maybe, or swap the filter caps, and fit a 7809. But yeah, I don't think anyone would really want to use an original SID with these. As I said, these only work in one direction. You can write to them, you can't read back, so oscillator 3 and envelope 3 registers can't be read from, and just a few SID tunes, well, maybe not a few, but a very small percentage of SID tunes need that. It can sound a bit strange on a nano swing SID, but like, I don't know, something like 95% of the SID library, you won't notice any differences. It seems to work flawlessly. So that's what I would just recommend that these guys leave on there. But you know, they could either, you know, fit a 6581 or an 858 if they wanted. Anyway, long story short, after all that testing, I came to test my card with the new cable. That wasn't working properly. This one, the one focus of this video, that wasn't working properly either. What was happening is I was adjusting the volume level here, and it was like really loud no matter where it was positioned, and there was like a noise when you switched it on. It was like, sounded like some oscillation or something going on. It took me blooming ages to work it out. I thought it was these amplifiers. I thought some of the amplifiers on these boards were different to the other boards, and that's not the case at all. It was all about the cable. Right, can you spot the difference? I'll give you a second. Actually, I'm not sure there is a difference. Yeah, there is a difference. This one here has got a resistor, a 1K resistor. That was one of the things I added into the final, you know, thing when I did the original video. Without the resistor there, you get some oscillation. It might not necessarily be oscillation. It could be that this has been overdriven on its output. Right, so this is one for Stephen with Stephen's cable. Just listen. Hear that? That's crazy, isn't it? Yeah, so I switched that off. Yeah, and it is all about this cable. I'm going to, let's say, stick a resistor in that. Let's just remove that out of the way. And we'll stick this one on. On a 2000 here, as I said in the previous video, it hooks onto the right side of R202. As you look at the board this way around. And let's just plug that on. Now the volume might be wrong here, I don't know, let's just try it. Yeah. I don't know if you heard that, it was a faint ding. So I just need to tweak that a little bit now, because now it's a bit too quiet. I have been messing with this obviously, but it's amazing the difference that makes. Let's just point downwards a bit. There we go. Just testing Stevens there, that seems fine. Let's just try the filter off and on. Yeah, that works. Filter's on. Sounds really good with additional filtering actually. So one thing of note, you know, this adjustment here, the volume adjustment, if you get it high, you know, higher than you need to, you start to get a bit of additional rumbling going on the filters, which can be a nice effect if you're trying to replicate a 6581 the way this is set up at the moment. But I've just pulled it down just a tiny little bit to fix that. I mean, I could show you that here if I just adjust this. Just wait for a bassy bit to come back on. Hang on. Well, I'll increase it there. Can you hear that? You get kind of like, I don't know, it's hard to explain. A little bit of a rumble. It certainly adds to the bass effect on the, you know, the filters. If you overdrive it. Right, let's pull it out. Let's test Stefan's. Yeah, those have been filed on the edges as well. I'll give them another go just to make sure they're a little bit thinner than they are now. Yeah, so I'm not sure if that pot is set right or not, because as I say, we had this that weird oscillating thing going on, and I think it was like a feedback thing or something. I'm not sure. Let's see. Yeah, I could barely hear that, so that's going to need some adjustment as well. Oh, that's working. Let's just turn the filter off and on. It's on at the moment. Yeah, you can hear a distinct difference when that filter goes off. Switch it back on. Yeah, I quite like it on. So there'll be a separate video on these. Let me switch that off. We've got the arm SID here and the back SID. I'm just going to try them, see what they sound like in here. Obviously get it the right way around with respect to pin 1. Let's get that in. So that's one nice feature I do like about the original Nano swing SID, actually, that ding. Well, certainly on an Amiga like this, it lets you know there's resets taking place. You wouldn't believe it, that's actually been helpful. I've been testing various Zorro cards. Sometimes you can get stuck in a reset loop where the swing SID will be going ding, 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 and you know you're getting resets. So we'll try Hyperball again there, just because I've just been playing that. Wow, actually I think that sounds better. The ARM SID does sound better. There was a noticeable difference there. Bear in mind filters are on at the moment on the Amiga. Switch the filters off. Let's just rewind that to the start. Let's go back to this track and the previous. Yeah, that bit just sounds way clearer to me on an ARM SID. I'm shocked actually, I didn't expect to be hearing a difference there. Now, one of the problems we've got here, I think maybe the amplification's a bit too high now for this particular SID. Anyway, call me impressed with the ARM SID in terms of, you know, this test here. Obviously, it's not much of a test. I'm not doing any side-by-side comparisons. I haven't captured any waveforms or anything like that. But we'll look at that in another video. I'm now going to swap over to the back SID. Periodically grounding myself on the power supply here, actually. Right, let's get the back SID in. Let's check the pins. Pins are a bit short on that, look. Quite short. Is that in? Yeah, it's in now. Yeah, whilst the pins were short on that, they're nice and firm. Right, let's get that. And let's give the back SID a try. Now I'm curious, will we get a ding or anything? No, that's another one that's silent on power. I would suggest to the manufacturers of both of those, have that ding. That ding is just so useful. The musician behind Hyperball, by the way, is Keith Tinman. It was always a favourite of mine, this game, though, because of the music, I think. Wow, that's struggling. That is a surprise. I think what's going on here is the timing of this is precisely coupled to the original design, isn't it? Something to do with the clock coming in, maybe. It's missing lots of stuff. That's a huge problem. Not what I expected at all. Switch the filter off. Yeah, I'll let the, it's Evie, isn't it? I'll let Evie know about this. But bear in mind, it's supposed to be in a C64, so I suspect it's, like I say, it's about the clock. It might not be, but, you know, the difference here in terms of the clock, well, A, the clock level's different, but also the frequency is different. On a PAL system it should be 0.98 megahertz, and on NTSC it should be 1.02. Now with this, it's got a 1 megahertz crystal that's just cut out. Anyway, we will be doing a separate review on that in a C64. Yeah, so he's taken into account everything we covered really in the first video. Massive thanks to Call286, really happy with this, it's amazing work, and thanks, special thanks to sparxUK for sending the boards out to us all in my Discord, but also gathering some of these components, the chips, the stuff, and I think the audio socket came from him as well, so very much appreciated. So I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.